Hello friends, today we are going to learn the binary search algorithm with its C code implementation. In computer science, binary search is also known as half interval search, logarithmic search, or binary chop, which is very often used algorithm to reduce complexity in coding questions. Let's try to understand the binary search through this example. We are given a sorted array having 10 elements from index 0 to 9. By the term sorted array, we mean an array in which the elements are arranged either in ascending order or descending order. In this video, we are going to work on an ascending one. Let us call this array by the name ARR, having the elements 1, 5, 17, 23, 30, 36, 41, 45, 52, and 60 at the position 0 to 9 respectively. We are interested to find whether a particular key called searching element is present in that array or not. If it is present, what is the index number? For instance, let's consider 52 in the array. We can directly see it is present at the array at index 8. Let's find this with the help of binary search. In the binary search method, we search an element in a sorted array by repeatedly dividing the search interval to its half. We begin with an interval covering the whole array. At first, we calculate the mid index and compare whether the element at the middle position of the interval is equal to the key or not. If the element is present at the mid of the interval, we simply return its index. If the key is not present at the middle of the array and the search key is less than the element in the middle of the interval, we narrow the interval to the lower half, otherwise narrow it to upper half. We repeat the same process till either the key is found or the interval coincides. Let's apply this method on our example. Let's consider three variables L, H, and mid, denoting the lower, higher, and middle indices of the interval. Initially, we have to operate on the full array. So, L is equals to 0 and H equals to 9 for the array ARR. Therefore, mid is equals to L plus H upon 2, that is equals to 0 plus 9 upon 2, that is 4. Then we compare the element at mid position to the key. Is the element at the fourth index is 52? The answer is no. So let's narrow the interval. Compare our searching element 52 with the element at the middle position of the array. If the element at middle position is greater than the searching element, shift to the interval L, mid minus 1. Else shift to the interval mid plus 1, h. Since 30 is less than 52, this time lower index L equals to 4 plus 1, that is 5, and higher index H equals 9 as before. Therefore, mid is equals to 5 plus 9 upon 2, that gives 7. Let's compare again. Is the element at 7th position is 52? Again the answer is no. Let's repeat the same method. Since 45 is less than 52, we move to the second half. This time, lower index L is equals to 7 plus 1, that is 8, and higher index H equals to 9 as before. Therefore, mid is equals to 8 plus 9 upon 2, that gives 8. This time, the middle element is equal to our searching element. Hence, we end the recursion and return the position of searching element, that is 8. So the binary search follows the divide and conquer paradigm of algorithm. In the searching technique, we divide the array in exactly half, and in each step, we try to find the searching element. The time complexity of binary search algorithm is order of log n. Since the algorithm divides the array in exactly half and compare the middle element in a constant time, the recurrence relation of the binary search algorithm is given by Tn is equals to Tn upon 2 plus C, where C is a constant time. The above recurrence relation can be solved either through recurrence tree method or master method. It falls in the case 2 of the master method and gives the solution order of log n. This is the algorithm for binary search technique. We have four parameters: the array ARR, the lower index L, the higher index H of the interval, and the searching key in the binary search function. This function runs only when the lower index is smaller or equal to the higher index passed. At first, we calculate the mid value of the interval. Then we compare the element at the middle position to the key. If both are equal, we return the value of mid. If they are not equal and the key is less than the element at the middle position of the array, we repeat the function for the first half and the indices L and mid minus 1 respectively. Else, if the key is greater than the element of the middle of the array, we move to the second half with the indices m plus 1 and h respectively and call the function. Let's see the source code for binary search in an. I am using code blocks for the program. You can download and install it from the link given in the description of this video. I am going to implement it in the C language. Initially, I am including the header files and creating two functions. One is our binary search function and other is main function, from which we call the binary search function to get our results. The binary search function has four parameters: the array ARR, the lower index L, the higher index H of the interval, and the searching key. The return type of the function is int. This function works only when lower index is smaller or equal to the higher index, else it returns -1. At first we calculate the mid value of the interval. Then we compare the element at the middle position to the key. If both are equal, we return the value of mid. If they are not equal and key is less than the element at the middle of the array, we repeat the function for the first half with the indices L and mid -1 respectively. Else if the key is greater than the element at the middle of the array, we move to the second half with the indices mid plus 1 and h respectively and call the function. In the main function or the driver function, at first we initialize the array ARR with the array in our example. Also we initialize the value of key, lower index and higher index to 52, 0 and 9 respectively. We call the function binary search with the parameters ARR, L, H and key respectively and store the result in the variable named result. If the value of variable result is -1, we print that no element is found, else we print the key and its position. Now our program is complete. Let's run the program. Here we go. The output is same as that in our example. Let's have a look on the C code of the program. Thank you for watching video. Please subscribe to my channel for more such videos.